So at this point we understand that vectors are things that have both a magnitude and a direction. There's a special type of vector that we want to talk about at this point called unit vectors. And unit vectors are defined to be vectors that have a magnitude of 1 unit. Now there's a particularly special set of unit vectors that are known as the Cartesian unit vectors. Because Cartesian unit vectors, whether you use I hat, j hat, or k hat, that's one way that you can refer to this set, or x hat, y hat, and z hat, that's the other way that you can refer to this set. But Cartesian unit vectors help define the 3 dimensions that we think of as x dimension, y dimension, z dimension. Now the other thing I'll go ahead and point out, you'll notice that when we've drawn a vector, it has a vector symbol. Looks like a little arrow. A unit vector has this hat symbol. So this little up and down, that hat symbol helps denote that something is this special type of vector known as a unit vector. So if I want to think about these Cartesian unit vectors, again, all of them have a magnitude of 1 unit. Sort of by definition, the magnitude of I hat, the magnitude of j hat, the magnitude of k hat, that's all 1 unit. And so if I want to think about their directions, well, one way to think about that is, again, to think about sort of what their function is. And so if I think about a 3-dimensional coordinate system where I've got positive x pointing to the right, positive y pointing up, and positive z is coming out towards us, I hat points in the positive x direction. So there's I hat drawn to the right. J hat points in positive y. So since positive y points up, j hat points up. K hat points in the positive z. So I hat, j hat, and k hat all have 1 unit in magnitude. They're all 1 unit in magnitude and point in the positive x, positive y, and positive z direction. Now, given what I hat, j hat, and k hat are, the fact that they help us define the x direction, the y direction, and the z direction, we now have a second way that we can report a vector. So we've talked about one way to report a vector is to describe its magnitude and its direction. The second way to report a vector is in unit vector notation. And the only sort of key thing to keep in mind here is if I'm going to use unit vector notation, then we all have to agree on what the coordinate system is. So I know which way I hat's pointing me because we all agree which way positive x points. And I know what j hat means because we know which direction positive y. So notice that what unit vector notation is it says we're going to take the 3 components. So ax, ay, and az. So the x component for vector A, y component for vector A, z component for vector A. And I'm going to multiply the x component times I hat plus the y component times j hat plus the z component times k hat. So when I do this, this is reporting a vector in unit vector notation. And again, if we think about what we said these unit vectors were trying to tell us, right? So I hat points in positive x, j hat points in positive y, k hat points in positive z. Then if you think about a particular vector, so here's an example. Let's take this particular vector A that happens to be negative 1.5 meters I hat plus 2 meters j hat plus 0 meters k hat. So just for ease of drawing, I've let the z component here be 0. So this is a vector that lies in the plane, in the xy plane, and it's got an x component of negative 1.5 meters and a y component of 2 meters. So here I'm reporting vector A, and again what this is telling me is since the x component of vector A is negative 1.5 meters, I can now interpret that to when I pair that with the I hat, what that's saying is vector A points 1.5 meters in the negative x direction. So you can think of it as the how far it points in the x direction is given by this number, and the plus or minus sign basically pairs with the unit vector to tell you in which direction. So my x component of negative 1.5 meters means that vector A points 1.5 meters in the negative x direction. Well, the y component is positive 2 meters. So again, I can now interpret that and say that that means that that vector A points 2 meters in the positive y direction. Z component was 0. Means that the vector A doesn't point in the z direction. So here vector A doesn't point into or out of the xy plane. So that's a special set of unit vectors, those Cartesian unit vectors. But we can also talk about unit vectors that point in any direction. And so one way to come back is, let's just think about some random vector A. Well, I know that vector A, because it's a vector, it has a magnitude and it has a direction. And so when I think about this notation, right, so the symbol on the left I know, that's just vector A. That first symbol I know, right, that's the magnitude of vector A. That last symbol, that's A with the hat on top of it. So from what we've seen so far, that seems like that would be the unit vector for vector A. So what does this mean? Well, basically, I know what that first piece on the right is telling me. Again, that's the magnitude, which would imply that this thing A hat must be telling me about the direction. And sure enough, A hat is the unit vector of vector A. It's indicating what direction vector A points in. So if I want to calculate that out, the unit vector for vector A, what I want to do is I want to take vector A and divide it by the magnitude of vector A. So I'm going to get this unit vector that points in the direction of vector A, which we're going to call A hat. Its magnitude is still going to be 1 unit, because by definition all unit vectors are magnitude 1 unit, and its direction is A hat is going to point in the same direction as vector A. So how do I build this unit vector A hat? Well, let's look at our example, the same vector we were talking about before. So the negative 1.5 meters I hat plus 2 meters J hat plus 0 meters K hat. And again, just going through this process, so when I think about what A hat is, again, it's going to be a vector with a length of 1 unit that points in the direction of vector A. So here's my I hat, magnitude 1 points in positive x. J hat, magnitude 1 points in positive y. K hat, magnitude 1 points in positive z. A hat is a vector with a magnitude of 1 unit that points in the direction of vector A. So to calculate that out, well, I can see that when I break up vector A and write it out in unit vector notation, that basically what that's going to be is it's going to be the x component of A times I hat plus the y component of A times J hat plus the z component of A times K hat, and then that's being divided by this scalar magnitude. And so that scalar magnitude distributes over all 3 of those terms. So this means that I can get the x component for A hat, this unit vector, by taking the x component of vector A and dividing by the magnitude. I get the y component of the unit vector by taking the y component of vector A and dividing by the magnitude. I get the z component of my unit vector by taking the z component of vector A and dividing it by the magnitude. So if I want to do this, well, the first thing I need to do is calculate the magnitude of vector A. Again, I know how to do that. I'm going to Pythagorize. In this case, I have a 3-dimensional vector, so I'm going to take x component squared plus y component squared plus z component squared. The z component 0, so it doesn't really add anything. But I do go through the same process, and I happen to get that the magnitude of vector A is 2.5 meters. So now I can come back and calculate the components of A hat, the unit vector that points in the direction of vector A. So I'm going to take the x component for vector A, which is negative 1.5 meters, and divide by the magnitude of the vector, 2.5 meters. That gives me an x component for the unit vector of negative 0.6. Do the same thing for y. The y component of vector A was 2 meters. The magnitude was 2.5 meters. Divide one by the other, I get 0.8 for the y component of the unit vector. Again, 0 was the z component of vector A, so when I divide by the magnitude, I still get 0 as the z component for the unit vector. So my unit vector is the vector negative 0.6 I hat plus 0.8 J hat plus 0 K hat. Now, one of the things we've said all along is what defines a unit vector is it has a magnitude of 1. So certainly I ought to be able to check and make sure that if my vector A hat is a unit vector, it has a magnitude of 1 unit. And so when I Pythagorize the vector a hat, so x component squared plus y component squared plus z component squared, take the square root, sure enough I get 1. So what this means is a hat is the unit vector that points in the same direction as a, just like I hat, j hat, and k hat are unit vectors that point in the x, y, and z direction. So we now have the ability to talk about our special Cartesian unit vectors, and then to figure out a unit vector pointing in the direction that any vector does.